Hello, everyone. My name is Eric Eichhoff, and I have the pleasure of serving John Carroll University as the Associate Director of Alumni Relations. I'm excited that you've decided to join us for JCU Jr, our new program aimed at providing our youngest members of the Blue Streak community with interesting and engaging programming. This summer, we are offering 5 sessions for you to enjoy. From baking to chemistry, poetry to zoology, we have something for everyone. Today, we focus on space. We have also created an activity book similar to the National Park Service Junior Ranger program for you to use. Kids who complete the activities will be an official JCU Jr graduate and receive a special certificate and JCU sticker. You may download the activity book on the Alumni and Friends website at jcu.edu/alumni. It is now my pleasure to introduce our guest presenter, Carl E. Walz, class of 1979 graduate alumnus. Mr. Walz is currently the Director of Business Development at Oceaneering Space Systems in Houston, Texas. Prior to Oceaneering, Mr. Walz was Vice President for Human Spaceflight Operations at Orbital Science Corporation in Dulles, Virginia, responsible for cargo and mission operations for Orbital's Commercial Resupply Services Program from 2008 to 2015. Mr. Walz has also held several positions within NASA. He had a distinguished career as an astronaut and is a veteran of 4 space flights, logging a total of 231 days in space. He was mission specialist on STS-51 in 1993, where he deployed the Advanced Communications Technology satellite and performed a 7-hour spacewalk. He also served as the Orbiter Flight Engineer, MS-2, and on the STS-65 in 1994, and was the mission specialist for STS-79 in 1996, mission to the Russian Mir space station. Mr. Walz was a flight engineer, FE1, on the International Space Station Expedition 4 in 2001 to 2002, where he performed science experiments, assembly tasks, and maintenance tasks. He completed 2 spacewalks, totaling almost 12 hours in both the Russian and US spacesuits. In addition to his NASA service as an astronaut, Mr. Walz served as the Director of the Advanced Capabilities Division in the Exploration Systems Mission Directorate at NASA headquarters in Washington, D.C. from 2006 to 2008. Mr. Walz is an Air Force veteran, retiring from active duty in 2003 after 24 years of service. Mr. Walz received his Bachelor of Science in Physics from Kent State University in 1977 and his Master's of Science in Physics from John Carroll University in 1979. He was awarded an honorary doctorate from John Carroll University in 2003. It is now my pleasure to introduce Mr. Carl Walz.
Well, thank you very much, Eric, for that kind introduction. And hello, everybody out there. Excuse me. We have Saharan dust blowing over, so I have a little bit of a frog in my throat. But anyway, I wanted to talk a little bit about what it's like to fly in space, and then a little bit about what's going on with NASA right now, because times are very exciting, and we have a number of different and new and exciting things that we're going to be doing at NASA, and it shows a great future for young engineers and scientists like you all want to be. So let me bring up my presentation here. Let's see, what's the best way to do this? Let me not bring this quite up yet. Let me go to share screen. And this one, share. Go full screen. There we go. Okay, so it's kind of an inner space to outer space. Talk a little bit about where we started from in the space program, what I did, and then where we're going. So outer space, the first satellites were very simple. They relayed radio signals and they took pictures, and then human spacecraft began even before more sophisticated autonomous satellites, basic radio satellites. And these human spacecraft became very simple, and then astronauts started to do spacewalks. You can see the picture there of Ed White on Gemini 4 doing that first spacewalk. Ed White wasn't the first person in the world to do a spacewalk. He was the first US astronaut, there was a Russian astronaut who actually preceded Ed White doing a spacewalk, Alexei Leonov. But you know, it's a very very amazing thing for that early in the human spaceflight programs to be stepping outside of a spacecraft. You know, because basically when you're in space, there's no air, you're in microgravity, and you know, there's a lot more radiation from the sun. So all those things are very hazardous. And here we are, we're actually walking outside of the spacecraft that was designed to protect us from all those hazards. So here's a picture from my first spacewalk. This was on the Space Shuttle Discovery back in 1993. As Eric said, I deployed the Advanced Communications Technology satellite from the payload bay. It's interesting because that satellite was managed from the Glenn Research Center, at the time the Lewis Research Center out in Rocky River. And so it's really, it was a great honor for me to be deploying that satellite, you know, for all the good folks in Cleveland, being a Cleveland native. So I'd like to talk about the space station because the space station is still flying right now. In fact, if you watched recently, there was a spacewalk where they replaced some of the older batteries with new lithium-ion batteries. And, you know, we're still, after, 22 years of the space station flying, still working on it, still improving on it. It's bigger and better than ever. And this picture shows the space station on top of a typical football field. And you could see that the space station is wider than a football field is long. And from the very back to the forward area, it's about 200 feet long. And it starts in a Russian segment in the back and it moves forward to a US segment. And then there's hardware contributions from Canada, from Europe, and from Japan. So it is very much an international undertaking. And we have a number of different astronauts from all over the world that have flown for long durations on board the International Space Station. It's about 1 million pounds of equipment. It travels right now at 17,500 miles an hour at an altitude of about 220 miles above the Earth. So at that altitude, we see a sunrise and a sunset 16 times a day. And we are on board 24 hours a day, 7 days a week. The space station has been manned since November 1st, 2000. So it's just an amazing achievement. The international community has just done an outstanding job of putting aside all the political problems and working together, and we're really proud of that. So this is a picture from inside the space station, and you can see I had an opportunity to bring along some items from the Cleveland area. So you could see the John Carroll University banner. I think you can still see that on display there at the university. And of course, I have my Cleveland Indians shirt and hat there. You can also see our speed limit of 17,500 miles an hour. This is at a location called Node 1. It was the first piece of the space station that showed up, and it connects to the Russian segment. If you go, if you float your way underneath that little banner, you'll go right into the Russian segment there. So what do we do on board the International Space Station? So this is a picture in the United States segment. This is the US lab, and I was doing a medical experiment. So one of the things about astronauts You know, we get to do cool stuff like spacewalks, and we get to fly space shuttles and space capsules. But we also have to do medical experiments because fundamentally we are guinea pigs for the space medical doctors and space medicine researchers that are trying to see what the impact of that space environment is on the human body. And so I'm hooked up to an experiment to determine what changes have happened to my reflexes. And the reflexes I'm talking about are the ones when you go to the doctor's office and they have the little hammer and they hit you on the knee. So that's that reflex that I'm investigating. And I'm sending an electric current through my leg, and my leg then will kick as that electricity travels through my leg, up my spine, and then back down. So it's just one of those things that we got a chance to do in space. Now, this looks pretty complicated. This is a picture from the Russian segment of one of the Russian experiments. And so this is a picture of my colleagues, Yuri Onofrienko from the Russian Space Agency, and my American colleague, Dan Bursch. So Dan was helping Yuri perform this experiment, and they were actually reducing the pressure on the lower part of his body and then measuring changes all over his body. So it was a very demanding experiment, needed two people to perform, and I'm sure Yuri was glad to get out of that contraption. And overall, this is a picture of the Russian space station. It's very similar in construction to the earlier Russian space station, the Mir station, that was free flying, and we visited with the space shuttle. And I lived on board the Russian segment during my time, my 196 days in space. So I had a chance to do 2 spacewalks when I was on board the space station. So this is a rehearsal for the first space for my second spacewalk. First spacewalk I did in the Russian spacesuit. But you could see these spacesuits are the US spacesuits. We're still using those 20 years later. The spacesuits are actually about 40 years old right now, and we're in the process of building a new spacesuit that'll be used on space station and then be used on a lunar surface. And I'm excited that I'm able to work on that with engineers on that program as well. But you could see all the different tools that are hooked onto the front of the spacesuit. We have a number of tethers because in space, things tend to float away. So inside, if they float away, we'll probably find them. We'll be able to track them down. But when we're outside of the spaceship and things float away, they're just gone. So we always have tethers on everything. And when we go outside, we are always tethered as well, because we as astronauts, when we're working outside the space station, can float away, and it can be a really bad day when that happens. So anyway, so that's a picture of us preparing to do a spacewalk. The airlock is in this part. If you could see where my little cursor is, you could see it's full of stuff right now. Airlocks, when they're not being used for doing spacewalks, turn into convenient closets on board a space station. And one of the places where we do our spacewalk training is in a place called the Neutral Buoyancy Lab at Johnson Space Center in Houston, Texas. And you can see there are large pieces of the space station represented in mock-ups or models of the space station, full-size models underwater. And down in this corner here, you can see the astronauts working, and they're practicing some of the tasks that they'll be asked to do in space. When they're working underwater, those spacesuits, because they're full of air, tend to rise up to the surface. And so The divers, you can see a whole bunch of these divers here, guys with the little yellow oxygen tanks. They have to put weights on the spacesuits so that the astronauts, when they're training, neither float toward the surface nor sink to the bottom. They have to be perfectly neutrally buoyant. So anyway, so it's an interesting application of that buoyancy, but it's an excellent training venue for us to practice our spacewalking. So some of the other things that we do as well is we do robotics on board the space station. The Canadian government provided a really large robotic arm that allows us to reach out and grab pieces of the space station and move them into position for assembly. It also allows us to transport astronauts around the outside of the space station. And we even use that robotic arm now to grab onto spacecraft that provide resupply to the space station. So that's a robotic space, the Robotic Control Center. My friend Ellen Ochoa is there operating the arm, and I was there to operate the cameras, because everything we have to do with the robotic arm, we have to do both visually and with cameras to make sure that we don't hit anything as we're moving the arm around. So when we're on board the space station, we are in microgravity. So we float everywhere while we're up there in space. And because we float everywhere, there's a tendency to lose muscle mass, and there's a tendency to lose bone mass. And so we actually lose weight while we're up there, and we lose a lot of our strength. And so to try to maintain both the bone mass and the muscle mass, we have to exercise. And so this is an example of some of the exercises that I was doing while I was up on the space station. And it's something called the interim resistive exercise device. And so since everything's weightless, we have to use elastic bungees to provide that resistance for our muscles. And so I did this kind of exercise every day while I was up on board the space station. And we also had a treadmill, and I would run on the treadmill. But because we're weightless, if we tried to run without something pulling us down to the track that moves, we'd float away. And so we always had more bungees pulling us down onto the treadmill. And then we also had an exercise bike as well that we would use to exercise on. And while we were up there, in addition to doing spacewalks and operating the robotic arm, we would have to do maintenance on board the space station. And so this is Yuri with that big gray thing, and that is our oxygen generation system. And so while we're up on the space station, we have to take water and turn that water into oxygen so we can breathe. And so that large piece of equipment was doing that job for us until it stopped working. And so at that point, we needed to do a quick repair. Unfortunately, we had another one of these large items available, and we were able to install that and begin generating oxygen again. As you know, you have to be able to breathe oxygen to continue to live. And so there was quite a bit of urgency to get that oxygen system back online. And, even in space, we have to take out the trash. And so these large canisters represent trash that we collected on board the space station. And some of it is bodily waste from the toilet, and then some other of the waste is just waste from some of the foods that we ate the packaging we collected up. So all of these things would go in a spacecraft called the Progress. And the Progress was a Russian spacecraft that would provide resupply while we were in space. And then as we took all the supplies out, we could take the trash and put it back in to that Progress spacecraft. When the Progress was all full of trash, we would basically then send the Progress back to Earth, and it would burn up. So anyway, so that's the story about taking out the trash. And we had time to have some activities, some hobbies while we were in space. There was a guitar up there when I arrived on board the space station back in December of 2001. And when I came up, I also brought that keyboard. And so I started out playing the keyboard. At the end of the day, I would have a few minutes left over, and I would play the keyboard. I brought up some music. And then about halfway through the mission, the music had guitar chords as well. So I picked up the guitar and learned how to play the guitar while I was up there. So Ken Cockrell, who's in this gray shirt here in the picture, was a classmate, astronaut classmate of mine, and he came up on the mission to bring us back to Earth. He was also a keyboard player in our astronaut band, Max Q. And so Ken and I did a duet while we were on board the station. So it was a lot of fun. You may ask, what other things would we do up there in our free time? Well, we had individual DVD players, and so we could watch movies when we were up there. As long as the DVD was on board the station, we could watch movies. And we had a phone where, when we had good communication coverage, we could actually call home. And so I would usually call my wife and talk to my kids once a day. And I'd call my mom once a week just to see how things were going. And that phone would work in the US. It would also work in Russia. So Yuri would call his wife and kids usually once a day as well. So this is just some of the things that we were able to do while we were up on board the station. And, you know, no discussion of living in space would be complete without a picture of our dining room table. And this is a view back into the Russian segment again. And this is where we took all our meals during my stay on board the space station. You can see the table here, and the table has areas where you can heat up food and where you could stick the food then to the table so it doesn't float away. So this is when Yuri, Dan, and I came up. So this is our crew here. The previous crew is here. Frank Culbertson was the U.S. commander, and Mikhail Torin and Volodya Dezhurov were the two Russian guys. And then in the middle here were the shuttle crew that brought us up and brought them back to Earth. And we shared a cuisine that was American, Russian, and Japanese while we were up there. So it was really cool. And when I lived on board the space station, as I mentioned earlier, I lived in the Russian segment. And so where I'm standing, actually floating here, that is my little sort of cabin, if you will. And I had a sleeping bag in there, and that's where I would sleep at night. We turn all the lights off, and then I'd sleep. So there you go. That's dinner time on board the space station. So I wanted to change over to what's new with NASA. And basically, we just saw astronauts launching from the US for the first time in 8 years with the SpaceX Crew Dragon Demo 2 mission. And you know, it was a beautiful launch. I had a chance to watch it on online, and then just some really cool pictures. of the flight deck on board that SpaceX mission. So that was very exciting. And the crew are up there still. In fact, Bob Behnken, who's the farther astronaut away in that very futuristic looking spacesuit, he was one of the guys that did the spacewalk along with Chris Cassidy. So we're waiting for Boeing to perform a similar feat, launching from the US with our astronaut crews to the ISS. And we're hoping to see that flight sometime later this year. And they call their spacecraft the Starliner. So the very exciting news about going to the moon revolves around the Artemis program and the NASA Gateway. And I'll talk about that. So there is a program called the Artemis program. So in mythology, Greek mythology, Apollo had a twin sister called Artemis. So Apollo was the god of the sun, and Artemis was the goddess of the moon. So NASA has renamed this program Artemis, and we hope to deliver the first woman and the next man to the lunar surface in 2024. That was something that Vice President Pence challenged NASA and the NASA contractor community to accomplish. And so we're working very hard on that right now. And I'll explain some of that. But basically, we would be building up something called the Gateway, which is a small space station that is in orbit around the moon, and that would become the base for continued lunar landings to the lunar surface. And NASA is working with the aerospace community in the U.S. and some of their partners, international partners, to develop these capabilities right now. And because we're going to a new destination, we need a new spacesuit. So I'll talk about that. We're planning to go to the lunar South Pole. We have found through a number of Earth and space observations that there is water ice on the surface of the moon, and particularly in the South Pole. So we're planning to go to the South Pole to see if we can find some of that water ice. So the way that we're going to get from the Earth to the moon is called the Orion spacecraft, and you can see that Orion spacecraft in that picture there. And it is a space capsule with a service module that provides power and propulsion. And here's a picture. You can see the service module. 4 crew members can fit into the Orion capsule. The service module is being developed by the European Space Agency for NASA. And then there's a spacecraft adapter that attaches it to the next large piece of equipment called the Space Launch System. Now here's another picture of the crew module. One of the things that Oceaneering is doing is developing an uprighting system. So those red sort of balloon-shaped objects are actually balloon-shaped objects, and they're supposed to ensure that the capsule, when it lands in water, will stay upright in the water, especially if there's waves or if it gets pulled over by the parachute. So all the new spacecraft that NASA is developing, the SpaceX Crew Dragon and the Orion are planned to land in the water. And I misspoke a little bit. The Boeing capsule is designed to land on land, and so we're looking forward to that. It actually demonstrated that recently, so we know that system functions very well. So I talked a little bit about the Space Launch System, and so what we're seeing in this picture is a rocket that we hope will launch for the first time in 2021. It's the largest rocket ever built. It has heritage to the space shuttle. These solid rocket motors are very similar to what flew on the space shuttle back in the day. There's a picture of the space shuttle with their solid rocket motors. And then the engines on the center section are the space shuttle main engines, now sort of recalibrated or re-engineered to fly in this configuration. And then you could see the Orion way up at the top there. And then on top of the Orion is something called the escape tower, the launch abort system. And it's very important because in the event of a problem with the rocket, that launch abort system will pull the astronaut, the space capsule and the astronauts to safety. So I talked a little bit about the Gateway. The Gateway is going to be in orbit around the moon. And the first two pieces of that Gateway hardware are being built. The first is called the power and propulsion element. And the engineers and managers at the Glenn Research Center in Cleveland are managing that program for NASA. So anyway, that's an exciting program there. And they're collaborating with a company called Maxar to build that system. And it's going to have a combination of electric and liquid propulsion. So very efficient propulsion. And then there's something called the Habitation and Logistics Outpost, or HALO, and that's being built by the Northrop Grumman Corporation out in Dulles, Virginia. Guys that I used to work with when I lived in Virginia are working on that right now. And then the Orion capsule will attach to that. SpaceX is developing a deep space logistics module to provide resupply to the Gateway. And then this is a representation of the Lunar Lander. So we're hoping that that Gateway arrives, or the elements arrive sometime in the 2024-2025 timeline. I mentioned the spacesuit. The spacesuit, sort of the red, white, and blue suit there you see with our NASA administrator, Jim Bridenstine. This is what NASA is developing right now. It looks very similar to the EMU, the current spacesuit, but it has an elliptical helmet, which gives you better visibility when you're working outside. And then it also has shoulders that better fit crew members, and the shoulders are actually can be resized easily so that you get a really good fit with your spacesuit. What we found is with the current spacesuit, a number of astronauts have injured their shoulders because of some so just not a real good fit sometimes in the old suit. So we're hoping to fix that. And then we have to have special lower, what we call the lower torso assembly. Basically, the pants of the spacesuit, they have to be specially made so that you can walk while you're on the surface of the moon. So NASA is working on this with its aerospace contractor team. And the company I work with, Oceaneering, is part of that. When about 5 years ago now, I worked on the spacesuit here on the right-hand side. It was very similar to the one that NASA is building now, and I got a chance actually to be one of the test subjects on that suit. It was really exciting to be getting back into a spacesuit again. And then the lunar landers, and so this is the newest part of this exciting plan. The lunar landers. The teams were selected at the end of April of this year. There's a team led by Dynetics in Sierra Nevada. This is the Dynetics Sierra Nevada concept for a lunar lander. It has elements from the Italian Space Agency, as well as 20 other contractors. So it's a big group of companies working together to put people on the moon. There's another team led by Blue Origin, which is owned by Jeff Bezos, who owns Amazon, and and that includes Northrop Grumman and Lockheed Martin. And then there's a third team from SpaceX, and that they're also developing a lunar lander. So the plan is to carry 2 crew members to the surface of the moon for up to 6.5 days. And we're trying to get there by 2024. It's a tall order, but NASA and its contractor teams are working hard to get there. So anyway, I just want to end with this picture. It's always pretty exciting to think about going to new worlds. And so I'll share that with you for now. And thank you very much. And I'm ready for questions.
Awesome. Thank you so much, Carl. That was incredibly interesting. And I know we have a number of kids who submitted questions about space and your experiences in space and where we're going next. So this is from Brody. He's age 9 and lives in Winter Park, Florida. How did you become an astronaut?
So Brody, that's a really good question. And, you know, I grew up in the Cleveland area and I went to both Catholic and public schools. And then, of course, I went to John Carroll and to Kent State University, both in Ohio. And there were 2 things. I knew that I wanted to be an astronaut, I think, from when John Glenn flew. So I had an ability to do well in math and science, and I was interested in that. So I pursued those subjects throughout my high school and college days. And then I also observed that most of the astronauts were military. And so I also joined the Reserve Officer Training Program out of Kent State University. They had an Air Force program. And so I got involved with that. And when I graduated from Kent State with my bachelor's degree, I also was commissioned a 2nd lieutenant in the Air Force. Now, my first job in the Air Force, oddly, I was assigned to as a nuclear research officer. And so I really wanted to go to Wright-Patterson Air Force Base in Ohio, would be close to home. That was not to be. I went to Sacramento, California. But out there, I got to meet people who had applied to become shuttle astronauts. And that was the key that unlocked the mystery of how to become an astronaut. They said, go to the Air Force Test Pilot School. And at the time, I wasn't an Air Force pilot, but they had a program for flight test engineers. So I went to the Air Force Test Pilot School, became a flight test engineer. I tested F-16s while I was there, flew in a number of different airplanes to include the F-4 and T-38. These are really old airplanes, by the way. And then started applying to become an astronaut. It took me 4 times to become an astronaut. So if there's one thing I want to tell you guys, it's if you don't succeed the first time, keep trying. Persistence does pay off, and that's a really important thing. So try again if you're not successful that first time. So that's how I got there. And then, you know, you get to the astronaut office and you try to work really hard, and you know, you get those opportunities to fly in space.
That is a phenomenal story, and I love the idea of keep trying, even if the first time it doesn't work out. So the next 2 are about how you felt like when you were in space. So Carmela from University Heights, she's age 5. She wanted to know what it felt like when you were in space, and then Lorraine from Chicago, Illinois, wondered what it was like going through all those G-force changes.
Okay. Well, Carmela and Lorraine, thank you very much for the questions, and they're very much connected. So one of the things when you're in space, the 2 things that really stand out is that you float everywhere when you're in orbit around the Earth, and so it's like swimming, except you don't have the drag of the water around you. So if you start going, you're going to keep going until you bump into something. And you don't get wet, and you don't have to hold your breath. And so it's really cool. So you just push off from one side of the of the spacecraft, and then you just will continue to float until you get to the other side. Now, with the space station being as long as it is, you can float a long time while you're there. And so we would try to see if we could float from one end of the space station to the other without hitting anything. That was one of the things that we did when we had spare time. So anyway, so that's what it was like. The other thing that was really cool about being up in space is you had this bird's eye view to Earth. The bottom of the space station always pointed toward the Earth, and we had a number of different windows. And so we could just sit and watch the Earth go by. Of course, we didn't sit all the time because we had work to do. But when we had some spare time or we had a little break, we would just sit and we would watch the Earth go by. And of course, one of the things that I really like to do is to look at the United States, to look at the places where I had lived, where I had visited, both daytime and nighttime. Because when you fly over the United States, there's a lot of people live in the United States, and you can see all the big cities at night, and they're lit up, and you can see all the big roads that connect all the big cities. So it's really cool. And then, of course, during the day, you can really see some cool things, too. You can see mountains, lakes. There's a place in New Mexico called White Sands, and it's basically this big dry lake full of this white sandy substance. And you can see that from space, along with some of the lava flows from some recent volcanic activity in the U.S. So that's just, it's really cool. So that's sort of, the sights and the feelings of being in space. So when you transition from being in a gravity field to zero gravity, it happens very abruptly. So on the space shuttle or on any spacecraft that's launching, as the rocket launches, you're pushed back in your seat and you feel G-forces as the rocket accelerates. Now with the shuttle, those G-forces were capped at three times the weight of gravity. But as you're accelerating, it's a sustained acceleration. So you're pushed back in your seat for 3-4 minutes at a time, and at 3 times the force of gravity. So it can feel very heavy, and some people reported that they had a hard time breathing while they were ascending towards space. And then as fast as that G-force comes on, as soon as the rocket stops burning, when you've run out of fuel, all of a sudden those G-forces go to zero and you're instantly floating. And for some people, it's kind of uncomfortable because it's like going over the top of a roller coaster, where all of a sudden your stomach kind of feels like it's falling. And some people do actually get a little bit nauseous and don't feel very good while that happens. So but you get over that, or most people do. There's a few famous people that don't get over it ever. But fortunately, I felt a little bit queasy, but got over it fairly quickly, and then you just go about your business. And then returning, it's a little bit different because you go from floating to a G field, and as you re-enter, the force of gravity jumps up to like 4 times the force of gravity. And here you are, you're used to being weightless, and all of a sudden there's this big spike of gravity pushing you in the spacecraft as you're re-entering. Now, the other thing that's cool about re-entry is the atmosphere is what slows you down. And it does that by friction of the spacecraft against the air in the atmosphere. And so the spacecraft gets very, very hot and it starts to glow. And so you're inside and you see this glow from inside. You're basically inside a meteor that's approaching the Earth. And so you know, and my mom watched us re-enter one time. She was at our house in Houston. She looked up and she saw us flying over, and we looked like this fireball coming over Houston, Texas, on our way to Kennedy Space Center. And so that's what we look like when we come back in. And then for the space shuttle, once we get to about 50,000 feet, we would begin to fly just like a regular airplane, and we would land on a runway. All the rest of the space capsules basically will get to about 50,000 feet. Parachutes will come out. They'll slow the spacecraft the rest of the way, and will land either on water or on land. So anyway, and then once you're back down, you're all of a sudden your muscles feel very heavy, and it's not so much that you don't have the muscle strength, but it's that your nervous system it just doesn't know how to calibrate your muscle system. So what I found is everything felt heavy for about the first couple of hours, and then I got used to operating in this Earth gravity, and I was able to function just fine.
I can imagine it's probably a very strange feeling the first time you do it. This question is from Hannah. She is 6 and from Kent, Ohio. And this was something I wondered too. What was your favorite space food?
Okay. Well, thanks, Hannah. That's a great question. And when I flew on the space shuttle, of course, all our food was made in the USA, and it's a combination of freeze-dried food, and then also some food that's in pouches, and all you have to do is heat it up. So similar to what some of our soldiers eat, the meals ready to eat. And so when I got to the space station, half the food was Russian food, and they had a slightly different system. Some of that food was rehydratable, but some of it was natural form, and it was in cans. And so these cans would be heated in a special heater that was embedded into that dining room table that I showed in my presentation. And so for the U.S. food, the important thing was to have a scissors to cut open the packages and a spoon to be able to spoon out the food. With the Russian system, you had to have a can opener to open the cans, and then a spoon to take out the spoon. Drinks, we had special drink bags, and we would, basically squirt water into the drink bags, and then we would put a straw with a little stopper to keep the water or the liquid in the bag so that it doesn't float out. What happens if water floats out of a bag is you get this big round ball of water because the surface tension holds it all together. And so it can be a big problem trying to get well, you really can't get it back in the bag. You just have to capture it with a towel. So I brought some examples of drink bags. So this is a US drink bag, and it's orange grapefruit drink. And this is the place where you stick this needle that injects the water. And there's like some Kool-Aid stuff down here, and you mix it up, and then you put the little straw in there where the needle went, and you can just drink that. And I used to put about 16 ounces of water in one of these so that it would look like this little torpedo. And we also have, if you could see that little blue thing there, that is a piece of Velcro. And so everything, we tried to have a little piece of Velcro on it so that you could stick it on the wall so it wouldn't float away. This is a Russian drink bag, and it's for tea. Earl Grey tea, Graf Grey. And you can see the little tea bag. And they had a slightly different system, but you still put the water in here, and you put hot water, and then you swish it around and let it steep just like a regular cup of tea, and then you would actually drink it out of this straw that you put the water in. And then we had, this is the little, it's like a thing that looks like bread, because it is bread. I mean, you can't eat it now because it's old, but we would have these on the Russian segment, and they were just like little loaves of bread. And then this is Ritz crackers, and we would get a chance to eat those while we were up there as well. So anyway, a little bit about food. And I actually ended up liking the Russian food better, believe it or not. It was new to me, and it provided a lot of protein. So I ate something called jellied fish, and I didn't think I would like it at all, but you know, you put some taco sauce on it and anything's palatable. So,
Understandable for sure. All right. Our next couple of questions are about more space in general. We actually have a submission from Switzerland. Kana, age 10, was wondering, why is space black?
So that's a good question. You know, I think the actual question is, why is the Earth's sky blue? You know, and because the Earth has its atmosphere, and so when the sun's high, as the light shines down, the light gets bent by the atmosphere, and the light that we see makes the sky look blue. There's no atmosphere in space, and so you know, basically where there's light from the sun, and then everywhere else, because there's no atmosphere, it's just black. So it's a very interesting thing when you're doing a spacewalk, because if you go behind the space station where you can't see the sun, it's dark. You know, unless you have lights, you can't see, even though you're in a sunlit part of the orbit, or unless you get some reflections from other parts of the space station. But it gets really black. It gets cold if you're not out in the sun. One of the things, landing on the moon at the South Pole, the sun is very low, and there, you know, it's either bright from illumination from the sun, or it's dark. And so with a very low sun, you get really long shadows, and that can be really tricky landing. And so that's one of the things we have to figure out, is how to make sure we land safely at that area. So there you go.
Thank you. We also had a couple of questions about Pluto. Wondering, is Pluto a planet? That's from a number of people, including Thomas, who's age 7, from Austinburg, Ohio.
Oh, okay. Well, those, you know, the Pluto question is a great question, you know, because we included it as part of the solar system for so long. Certainly when I was growing up, Pluto was the 9th planet. But when you really look at Pluto and you look at the weird orbit that it is relative to all the rest of the planets. So if there's, when you look at the solar system, there is a plane where all the planets are kind of lined up on the plane. It's called the ecliptic. All the planets are lined up except Pluto. Pluto is at this wonky orbit, and it's way, way out. And so the theory now is that Pluto was an asteroid, a really large asteroid that was captured by Earth's orbit. And because it was coming from outside of the solar system, the orbit that it has is not in the ecliptic. So they feel that everything that was on the ecliptic was part of, you know, basically the same stuff that the sun is made out of. But because Pluto is kind of this other angle, not on the ecliptic, the feeling is that it probably came from somewhere else. And so they don't really call it a planet as such. They call it a planetoid or a minor planet. There's a lot of discussion about minor planets. There's a lot of places between the orbits of Mars and Jupiter. It's called the asteroid belt. And there's some minor planets in there too. There's an asteroid called Ceres, and we recently sent a spacecraft there to map that out. So it's, I mean, Pluto's pretty big minor planet, but it's still pretty small and it's pretty kind of wonky. So, but you know, we had that New Horizons spacecraft that went out there, took some pictures, just phenomenal stuff, and it's very exciting to see that, and I hope we study it some more, because out there is you know, some of the space stuff that that the Earth was made out of.
Very cool. I know that's one of those things where you learn one thing and now it's not, and then you learn it again, and it's always wondering what Pluto is. So we had a couple other. We have two more questions for you.
Okay.
One is from Mario and a couple other people too. Mario's 6 and was wondering, what is a black hole?
Okay. So Mario, good question. So the black hole is something it's a sun that has collapsed in on itself, and so the stars that we see, including our sun, are balls of primarily hydrogen gas, and they're you know, just a lot of it all together, and the gravitational force pulls it all together, and that hydrogen heats up and starts to glow and starts to fuse with other hydrogen atoms, and it's like a controlled hydrogen bomb. Only the gravity keeps it all together, and energy is released, and that's the energy that warms us and, you know, all the other planets in the solar system. So what happens over time is that hydrogen fuel is not limitless, and it gets turned into helium and carbon and all sorts of other elements, and eventually it just runs out of juice, basically runs out of that fuel, and the star collapses in on itself. Now, depending upon the size of that sun when it was burning, it can do one of two things. It can turn into a white dwarf, or it could turn into a black hole. So black holes are just stars that collapsed in on themselves. And there's some really interesting mathematics that governs that. And there's something called the Schwarzschild radius that tells you whether you turn into a white dwarf or your sun turns into a black hole. But you know, it's stuff that I don't remember anymore. I learned it once, and it was really cool. But there's a lot of these black holes around, and so that's one of the exciting things is in astronomy, finding these black holes, and we find them because they suck up other planets and other stars, and as those planets and stars get sucked up, they emit light, and we can see that with our telescope. So it's an amazing thing. Science in every aspect, you know, from the very smallest, you know, viruses and microbes, all the way out to these gigantic planets. It's all really cool stuff.
Yeah, definitely. And yeah, black holes are obviously something that every kid's interested in at some point. So our last question is something you alluded to earlier. And it comes from Lauren. She's 10. And she was wondering, what memories were you recalling when you watched the SpaceX rocket take off earlier, just a couple months ago?
So that's a really, really good question, because I did watch it. I was really excited. So I watched both the launch and the early parts of that post-launch period, and then about, I guess it was the next day, they docked with the space station, and I watched that as well. And just, you know, all the memories of launching from Kennedy Space Center came flooding back. And, you know, they were all good memories. They were really exciting. Just the feeling that the crew must have been feeling as they were launching into space. and then arriving on board the space station, and they'll be up there probably 2-3 months, doing experiments and then doing these spacewalks. So it's some really great memories. I wish I could do it. I don't want to do the training over again. Thank you very much. I did 4 years of training for the space station. That was enough. So, but the flying on board space station, especially the long duration flight, was really, really rewarding. And the opportunity to work with the international crews was very rewarding as well. I think that's one of the most important things that has come out of the space program, I think, is the international cooperation that NASA has fostered with all the other countries around the world. And I hope that continues, hope it expands. The next thing is this commercial space flight, commercial tourism in space, and going to the moon, and hopefully going to Mars, not too far behind that. So exciting things. NASA's right on the forefront, and I think there's some great future ahead for all the students now that are young and looking for what they want to do when they grow up. So I wish you all the best, and thank you very much.
Well, Carl, thank you so much for your time and your willingness to be part of JCU Jr. I know all of our JCU Jr. members have enjoyed learning from you and hearing about your experiences. Additionally, I would like to thank you for your service to our nation. We are truly grateful for all that you've done and all that our men and women in uniform do to protect the freedoms we enjoy today. To all our alumni and their families, thank you for joining us today. We are glad that you did. I encourage you to take part in other JCU Junior programs along with our Alumni Continuing Education series. You can find out more about these programs on jcu.edu/alumni. Thank you again, and I appreciate you being here and look forward to seeing you again soon.
All right, Eric, thank you very much.